Hi everyone, in this video I'm going to look at the basics of a histogram and what we can see looking at a histogram, what it tells us about the data. So here's an example of a histogram and I want to point out some of its features. So we're looking at a graph here. The title at the top is Enrollment in Denver Schools. So this is telling us about what data we're looking at. For histograms, you're looking at typically one variable, one piece of data. In this case, that's enrollment, and that should be appearing along the bottom or the horizontal axis. So the title on the horizontal axis here says enrollment. This represents a number of students. It's good practice to put units here if the units wouldn't be clear, but these are just basically counts of people or counts of students. And you'll see that this is a numerical axis. In this case, it's going from 0 up to about 2,500. And the data is grouped into these ranges or intervals that we call either classes or bins. So in this case, the first class goes from 0 to 499, the next one from 500 to 999, 1,000 to 1499, and then the last class ends up at 2499. So each school, their enrollment number is placed into one of these classes, and then we are counting how many schools fall into each of those ranges. And that information is what's displayed on the vertical axis. So here this is labeled with frequency. It's going from 0 up to 200. And so in the graph, we have these bars. So histograms, the bars have both a width and a height. The width represents the interval or the class. So this first bar goes from 0 to 499. That's representing a range of values on the horizontal axis. And then the height of the bar represents the frequency, or how many, in this case, schools had an enrollment in that range. So the first bar, the height looks like a little over 150. So more than 150 schools had enrollment between 0 and 499. The next bar, if I look at it, is the range from 500 to 999, and the height is just about 50. So about 50 schools had an enrollment between 500 and 999. So that's how we're reading this. Each of these bars, the width is telling us what range of data values we're looking at, and the height is telling us what the frequency was, or how often those data values showed up in the data. I wanted to show a couple different versions of histograms. There are different styles and different labeling techniques. So in this example, we're actually looking at the same data. The title and the horizontal and vertical axes have the same labels. The class intervals are a little bit different. So looking along the horizontal axis, the first class is going from 16 to 516. This graph was created using the built-in Excel histogram tool. Just to show you what that looks like, if you're on the Insert tab in Excel, in the center chart icon, there is Insert Statistics Chart, and one of these is Histogram. So if you highlight your data and press this button, Excel will create a histogram for you. So I used that histogram tool to create this histogram from the same data as from the previous histogram we looked at. And what's a little funky about the Excel histogram tool is that it chooses its own classes. I did specify to use 5 classes here, so we'll see along the enrollment axis or the horizontal axis there are 5 intervals across, but the numbers that it chooses are often a little strange. So the notation here, the first interval has bracket 16 comma 516 bracket. That means numbers from 16 to 516. This is interval notation. And the brackets mean that we are including 16 and including 516. The next interval is parentheses 516 comma 1016 bracket. So this is saying from 516 students up to 1,016 students, including the 1,016 with the bracket, but not including the 516 with the parentheses. And the next intervals are similar, where the lower bound is not included and the upper bound is included. Each one of these intervals has the same width. The final interval ends up ending at 2,516. So the divisions are a little bit different from the previous graph, and because the divisions are different, the frequencies, the counts for each of these ranges are likely a little bit different as well. The labeling on this frequency axis is a little different than what we saw in the previous graph. The previous one had labels every 50, this one has labels every 20, so 0, 20, 40, 60, etc. But it's still displaying the same data. We're still seeing kind of the same general shape. It's still, is representing the distribution of this enrollment number. It just looks a little bit different because we're using a different tool. Here's another example. This graph I took from the OpenStax Introductory Statistics 2nd edition book, just to have a different example. So this is looking at different data. So in this histogram, the horizontal axis is labeled heights. And I'll talk about the scaling here and how it's being labeled in just a moment. The vertical axis is actually not frequency, but rather relative frequency. So this is not a traditional histogram, but a relative frequency histogram, meaning that instead of showing the count or how many, in this case, I think they're talking about people, how many people have any particular height, it's looking at what percentage of the total had that height. So if I look at the very first bar here, the width of the bar goes from 59.95 up to 61.95. Those are representing a range of heights. And the height of the bar is 0.05, and you'll notice that these bars are actually labeled at the top of each bar just to make it easier to read, but that is the height on that vertical scale. So 0.05, that would indicate 5% of people, or whatever was in this population, have heights between 59.95 and 61.95. And so each of these bars, the next bar from 61.95 to 63.95 has a height of 0.03. That would be 3% of the total population. The highest bar we're seeing here is roughly in the middle from 65.95 to 67.95, and the height of that one is 0.4, so that is 40% of all of the data is in that kind of mid-range there, and then we have various other percentages for the other bars. Relative frequency histograms can serve the exact same purpose as histograms with just plain frequency. They'll still show us the distribution of the data. The only thing that we don't have here is the sense of how many items or numbers were in the total data set. So something that is different about this particular graph, other than relative frequency, is how they're labeling the different classes. So this graph is using what are called class boundaries. So 59.95, 61.95, 63.95, these numbers that are labeled along the x-axis. These represent numbers that fall right in between each class interval. So in between the first two classes is 61.95. The class intervals that they likely used for these classes were 60.0 to 61.9, 62.0 to 63.9, 64.0 to 65.9, etc. You'll notice that if my first class ends at 61.9 and the next one starts at 62 or 60.2.0, that class boundary 61.95 that falls right in between my two classes is exactly halfway between where one class interval ends and where the next class interval begins. Depending upon how you're talking about histograms in your statistics class, you might be using class boundaries or you might just stick to the class intervals. It's really just a difference in labeling, and as long as we're clear what numbers are going into which intervals or classes, it doesn't really matter how you label it. We do want to make sure that the classes are all the same size. We want to make sure that they don't overlap with one another, and we don't want the class intervals to have gaps in between them where certain data values can fall. So if my first class interval ends at 61.9 and the next one starts at 62.0, I would want to make sure that none of the height values that we have in our data set fell in between 61.9 and 62.0. Other than just looking at these individual classes within our graph and finding the height of each of those classes to find out how many data values were in that range, The reason we create histograms is really just to get a visual picture of the distribution of this data value. So if I'm looking at my heights histogram, I'm not necessarily looking at each individual bars. I'm looking as a whole and finding some key pieces of information about those heights. So first would be a rough estimate of the center of the data. So we could be talking about the mean or the median, which is something we would measure directly from the data. But in our histogram, if I'm looking at my heights histogram, I see that I have relatively small bars on the lower and upper height ranges, and then we have one particularly tall bar in the middle between the 65.95 and 67.95. That means most of the heights were in that kind of middle range, and then fewer of the heights just above and just below that, kind of tapering off in both directions. So the center here would be roughly where that middle bar is, around 66 it looks like. One thing that I forgot to mention earlier, these heights are not labeled with inches, so that is something that we probably would want to add to this graph if it was our graph. Are these inches, centimeters, meters, right? Depends on what we're measuring. So the center of the data is just kind of the visual center, imagining maybe balancing this histogram, these histogram bars on a balance point. Also the spread of the data. So what are the lowest values? What are the highest values? Are the data values mostly grouped in toward the center? Or are they more kind of evenly spread throughout the range? So in this case, most of the data values were towards the center, but we do have data values going down to about 60 and up to about 76. So that gives us a sense of the range. These are not necessarily precise numbers because I don't know, for example, in the first class from 59.95 to 61.95, I know that 5% of data values fell into that range, but I don't know where within that range. So I'm not getting a precise sense of the center or spread, but I am getting kind of a rough visual estimate of those key components. Another thing you can look for in a histogram are any obvious outliers. So in particular, you would be looking for gaps where certain classes maybe didn't have any frequency, and then we have a little blip off to the right or off to the left. This particular graph doesn't have any obvious outliers, but if you have a bar off to the right-hand side or off to the left-hand side with just a couple of individuals in there, that could indicate some outliers that are sort of further away from the majority of the data. The last and even maybe the most significant pieces to look at with histogram are just the general shape and then how many peaks, which is called the modality. So in this example we've been looking at, there's just one peak in the middle. This would be unimodal, meaning that there's sort of one peak in the data. And this distribution is roughly symmetric. Since it has a peak towards the middle and kind of tapers off on both ends, we would probably call this a roughly normal distribution. I'll talk in more detail about what distribution shape and the modality looks like in the next video. That's it for this video. Thanks for watching.